Okay, so here we've got a set A of people, set B of jobs. Yeah, so then for each B and B, then we got a number I'm going to call MB, at least 0. And a set CB as usual. Of qualified people. So I want to recruit a team of size MB for each job B. Okay, so before we were just having one person for each job, but now we need a team of people for each job, different sizes of teams for different jobs, maybe. Okay. So so in this team allocation context, we have a slightly different definition of plausibility. Okay, so the deal is that the number of candidates should be equal to the sum of the team sizes needed for the jobs in B. And be convenient actually to define M subscript U is this number that we're looking at here. Okay, so MU is the total team size required for all the jobs in U. So the plausibility condition is that the size of CU should be greater than or equal to MU. And then the theorem, team allocation, team version of Hall's theorem is that basically the same thing, except that the definition of plausible has now changed, right? So there's a team, there exists a solution in which we allocate a team to each job of the right size, and everyone's qualified if and only if every set is plausible. So again, this is not very hard to prove just by reducing it to the usual version of Hall's theorem. So what we do is we make a set of badges. Okay, okay, so we make a job. So you need, if you need, 17 brain surgeons, say, then you make badges which say brain surgeon 1, brain surgeon 2, up to brain surgeon 17. Okay, so to make all these badges. Okay, so who's qualified to wear these badges, right? I mean, you've got the badge which says Brain Surgeon 6. The people who are qualified to wear that badge are the people who are qualified to be brain surgeons, in other words. So the people qualified for this badge is just people qualified for badge CB, badge BI is just the set CB. And so now so now our problem is to allocate the badges. Okay, so if you've allocated every badge to a qualified person, then and different people get each badge goes to at most one person. Each person gets at most one badge, then that just solves the team allocation problem for you. Okay, so suppose we've got a set U star of badges. And then let U be the set of job titles that appear on at least one of these badges. Okay. Okay, so then the candidates for this set of badges is just the same as the original candidates for this set of jobs. So sorry. Okay, so the number of candidates is number of candidates for these badges is at least as large as MU. But also U star is a subset of all the badges for the jobs in U. And so the size of U star is at most MU. So combining 1 and 2, we find that the size of U star is less than or equal to the size of CU star. Okay, this works for all U star, therefore the badge allocation problem is solvable. Okay, and that's what we needed to do. Okay, so if we can allocate the badges, then that allocates the jobs in the required way. And that will do for this lecture.